All right, friends, today was arguably a bit of a disaster. So hopefully you filled out the Google form or the Google Doc so that I can kind of preemptively strike on who you really want to be in a group with, and I can get a jump start during class on forming those on the other days so that that doesn't have to take so long. I still really want you to have the opportunity to work together, so we're going to just work together to make that a little bit more efficient. In case I completely confused you with my bad examples and confusing everything, I'm going to walk through these 6 that you may or may not have had time to work on in your group. So, keeping in mind that the first plan is probably to open up what you need in Notability so you can write on it. The first thing you want to do is you want to get it equal to 0. So in this case, I would have x squared plus x, and to move that 6 over, I have to subtract it. Now I have to look for 6 in a way that will subtract to be 1. So I'm thinking about the ways to make 6, and then this combination of 2 and 3 is going to be my best bet because it will multiply to be 6, but subtract to be 1. Now this 1x is a positive, so I would need a positive 3 and a negative 2. Then each of these has to equal 0, one or the other, because like 0 here times anything would be 0. So in order to make that first one a 0, I would need to use a 2, meaning if you plugged a 2 in here, it would turn the whole thing into 0. Same kind of thinking on this one. In order to get a 0 out of that factor, my x would have to be a negative 3. So tying back to what we've been doing in the past, that would tell me that at 1, 2, 3, and then 1, 2, it's going to cross the x-axis. Then you could go back here and say, oh, I have a positive x squared, so it's going to be going up. We could do our opposite of b over 2a to get the vertex and so on. So we would be able to draw this with even more accuracy than we were able to do before. Okay, let's move on. Now, some people did and some people did not watch the factoring video. If you have not done that from before, you're gonna have to go back and kind of find that in the last couple of weeks. It was the thing you were supposed to do after you took the 4142 quiz. So if you look back at the weekly plans, you can find the link to that video, or if you go into chapter 4 videos, it should be there. And in there, it talks about the greatest common factor, which is always the first thing you look for. Particularly if you have something weird like this, because this isn't the typical 3-part setup. If you look at this problem, you can take 12n out of both of these terms, leaving you with n minus 2. And then the thinking is the same. What would it take to make this factor equal 0? A 2. That one's pretty straightforward. But then this one's weird. But think about it. What would it take to make 12 times n be 0? Well, n would have to be 0. And then everyone thinks they did it wrong. But 0 is a number too. So if you were to go to graph this, it just means that at 0 and positive 2, you're going to get your x-intercepts. And you could go back and find the vertex and everything else from there. I'm looking at this. I know that it's going to open up, and so I can go back and find the rest of my info. In number 3, I need everything on one side, and I don't love that negative in front of the y squared. So what I'm going to do is I'm going to move the y squared over and the 49 over by addition so that my problem reads y squared minus 14y plus 49, and then that's going to be equal to 0. Then when I go to split it up, I'm looking for ways to make 49, which there's not a lot. I can do 1 times 49 or 7 times 7. So considering that they have to add up to be 14, I'm going to go with 7 and 7. Considering that I would need a negative 14, I would want them both to be negative, because combining a negative 7 minus 7 more will land me at that negative 14. So that has to equal 0. What's confusing about this is both of the zeros turn out to be 7. And so I think like the thing I don't love about answering questions electronically, like on that Schoology quiz, is they're the same thing. And so if you had 2 blanks, you would have had to write 7 in both of them to get it right. And if you only answered 1, you might have missed a point. So I'm not going to worry too much about the point values on this. I just wanted to kind of get through that and see if we were able to complete a task and then enter it in Schoology and just sort of practice some of those things we're going to have to do. But what this one is telling me is if I graphed this, it would only touch once there. So I would end up with at 7, my parabola, and keep in mind once it's in standard form, this is still positive, and so it must just sit right there. It's the only way that it could only touch in one spot. It could also open downward, but my y squared in standard form is positive. All right, so here we go. Let's take a look at this one. I still need this to be equal to 0, so I'm subtracting the 49 over. And again, referring back to the factoring video, you are supposed to check for a greatest common factor. Well, this one doesn't have one. And so then if you watch that video, it split off into what do you do if there's 2 terms, 3 terms, and so on. The majority of them have 3 terms, like number 1, and we know what to do. But when you got to the part of the video that talked about 2 terms, you either had to be able to take out a greatest common factor like we did here in number 2, or you had to look for something called the difference of squares. And again, this is in that video, where you have something squared minus something squared, thus the name, difference of squares. What you have to think of is, what are they each the square of? So kind of in your thinking, you're saying, what's this, if I square rooted my a squared, what would I get? If I square rooted my b squared, and you would end up in that case with a's and b's. And then the factoring process involves the sum and the difference. Because if I went ahead and FOILed these out, I'd end up right back where I started, which is the goal. So in this case, 16m squared is the perfect square of 4m, and 49 is the perfect square of 7. So those kind of become my A and my B, and when I write out my 2 factors, I'll have 4m plus 7 and 4m minus 7. And then in order to get those to equal 0, you can either write it out and then just kind of visualize that you'd be taking away the 7 and dividing by 4. Or you can start to kind of realize that what's happening all the time is you end up taking the opposite of this number, because in the solving process, it gets moved to the other side, and then it goes over that number. So what I'm saying is, for example, in this part, I would have used the opposite of 7, which is negative 7, and then over 4. If that's tricky, then just keep writing it out. So you could write this one out, or you can think, I'm going to take the opposite of negative 7 over 4. And you'll get the same thing either way. So whatever your comfort level is with kind of understanding where you're going to end up. All right, so then let's take a look at this one. This one is, again, one of the other types that I talked about in that video and tried to talk about today during like disaster example time. Here's one where you have an A value out front, and that makes it kind of messy because you can't just pretend it's not there. So what I do, and again, if you have a different method you've always done that works, don't go changing to try and please me. So I'm going to leave that as an 8 for now, knowing that I'll have to reduce. I multiply the front and the back end, and in this case, I just get the 8. Now I'm going to split that 8 up in a way that will do what it normally has to do, which in this case is add up to 6. So if I think about that, my options for 8 are 1 times 8 or 2 times 4. The only one that adds up to 6 is a 2 and a 4. Then I pay attention to the fact that this 6 is negative, so these would have to both be negative to get a negative 2 minus 4 more, turning into that 6. The key thing is, if you do that fake way by leaving these both as 8s, you have to reduce one or both of them by something. And in this case, I can divide out a 2. And here I can divide out a 4. And those just disappear because I kind of, in this one up here, just fake, like expanded my numbers. I let them both stay 8s. But in reality, if these were both 8s, when you multiplied them together, they'd give you a 64 here, not an 8. So I knew that I like inflated my numbers to work with so that over here I wouldn't have to guess and check. But since I inflated them in my work process, I need to deflate them back down again to the real numbers that would work. Because again, the way to check is if I FOILed this, I would end up right back with what I started with. And then the zeros that would go with these, from here, I'd get a 1/2. And from here, I'd get a 1/4. And again, if you need to go through the process of setting them equal to 0 and solving, you certainly can do that. Last example, I'm going to go ahead and move everything to one side by subtracting that 18, set it equal to 0. And in this case, I see that I can take out a greatest common factor. So I pull out the 3, and it leaves me with a different problem, obviously. This 3 cannot become 0. Up in this other problem, right here, number 2, when I pulled this 12 out as a greatest common factor, and n came with it, and so because it's 12 times n, it's possible to turn that part of the factor into 0 by using 0 for n. Here, this 3 is just by itself, so it can never be 0, and it will not contribute an answer or a solution to what we're trying to do. So only zeros we're going to get are from this remaining portion. To get 6, I have the option of 1 and 6 or 2 and 3. Now be careful with this one because you have to pick one that subtracts to be 1. So I'm going to pick the 2 and 3 option. And then I'm going to look and say, okay, I'm trying to get a positive 1. So I would need a positive 3 and a negative 2. But those are factors, not solutions. So my solutions would be from this one, a positive 2, and from this one, a negative 3, because zeros are the opposite of what you had as factors. And then that's going to tell you where that parabola would cross. So when I go to Schoology and I try to answer all these problems now, like I'm going to type in, it'll open up and it'll say, what was your solutions, for number 1? And you would simply type 2 as one of your options and negative 3 as the other. You do not have to write x equals. So you're just typing in the numbers. And if you get something like a fraction, it says in the instructions to leave it as an improper fraction. So you would type it in as negative 7/4 and your other answer as positive 7/4. So even if you already did this, I did reopen that for submissions. So if watching the video helped, which it should, because I just gave you all the answers, you can go back and try typing them in again. And then that way, when I look at it, everybody should have a 6 out of 6, or actually it'll be 12 out of 12. The only thing that's weird is here in number 3, I believe it makes you answer 7 both times because both of your answers were 7. So even if you did it, you should be able to go back and do it again. I opened it for a second submission. And so anybody who has any stress about it whatsoever, you can watch this video and then you can go back and re-answer them. I look forward to seeing you Monday, and we're going to just hope that Monday goes smoothly, and I'm going to have awesome Wi-Fi and awesome examples, and life is going to be good, and you're going to be relaxed and full and happy. I will see you then. Bye, guys.